Today's lesson is on perfect squares and square roots. So this first section is basically telling you the different terms and the definitions. So a square is the product of a number and itself. So for example, the product of 6 and 6 is 36. 6 times 6 is 36. Square root is one of two equal factors. The square root of 9 is 3, because 3 times 3 equals 9. The radical sign is the symbol used to indicate the square root of a number. And a perfect square is a number whose square root is a whole number. So for example, 16 is the perfect square because the square root of 16 equals 4. 4 is a whole number, not a decimal or a fraction. So next, perfect squares. You can see here 2 times 2 equals 4, 3 times 3 equals 9, and 4 times 4 equals 16. It says, are the shaded portions squares? Answer is yes. And it says why? Because they are products of a number of them, of a number. And its self. So examples of perfect squares. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 equals 9. 16 is a perfect square because 4 times 4 is 16. Now, we have a list of perfect squares that I want to get through. I'm not going to go through all of these because you can also use your calculator and use the squared button on your calculator to find these. But what I do want to show you here is how you find those perfect squares without your calculator. So 1 squared, and I'm not going to do all of these, but to find 1 square would be 1 times 1, which would equal 1. 2 times 2, which would equal 4. 3 times 3, which would equal 9. 4 times 4, which would equal 16. 5 times 5, which would equal 25. And so on. So as we go through these, 6 times 6 then would be 6 times 6 here, which would be equal 36. And I am going to actually go through these very quickly. So 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16, let me move this over just a little bit, is 256. 17 times 17 is 289. 18 times 18 is 324. 19 times 19 is 361. And then 20 times 20 is 400. So next, a square root of a number is one of its two equal factors. Okay, remember, it's a factor. So 4 times 4 is 16. So 4 is the square root of 16. Or the square root of 16 equals 4, and that's how we write it. The symbol here is called a radical sign, and it is used to show a number's square root. Now, examples of this: the radical sign or square root of 4 equals 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16. And I don't know why this came out like this, but these should be going over like this. So I'm going to fix these like that. And the square root of 25 is 5 because 5 times 5 is 25. And the square root of 100 is 10 because 10 times 10 is 100. So next, it says find each square root. Think what times itself gives you 81. Well, the square root of 81 is 9 because 9 times 9 is 81. The other thing you can do, excuse me, is put in your calculator the square root of 81 and it'll give you 9. The square root of 225 is 15. The square root of 4, as we just set up at the top there, is 2. The square root of 196 is 14. The square root of 121 is 11. The square root of 36 is 6. The square root of 49 is 7. The square root of 16 is 4. And the square root of 64 is 8. Now, the next thing that we're going to look at is the perfect square roots and the perfect squares for 1 through 20. Now, here, we are going to use our calculators, and that way we can just kind of write them out. And therefore, I have the square root of 1, or the square of 1 is 1. Therefore, the square root of 1 is 1. 2 to the second power, or 2 squared, is 4. Therefore, the square root of 4 is 2. 3 squared is 9. Therefore, the square root of 9 is 3. 4 squared is 16. Therefore, the square root of 16 is 4. 5 squared is 25. Therefore, the square root of 25 is 5. 6 squared is 36. Therefore, the square root of 36 is 6. 7 squared is 49. The square root of 49 is 7. 8 squared is 64. The square root of 64 is 8. 9 squared is 81. And the square root of 81 is 9. 10 squared is 100, and the square root of 100 is 10. So to go through 11 through 20, we have 11 squared is 121, and the square root of 121 is 11. 12 squared is 144, and the square root of 144 is 12. 13 squared is 169, and the square root of 169 is 13. 14 squared is 196, and the square root of 196 is 14. 15 squared is 225, and the square root of 225 is 15. 16 squared is 256, and the square root of 256 is 16. 17 squared is 289, and the square root of 289 is 17. 18 squared is 324, and the square root of 324 is 18. 19 squared is 361, and the square root of 361 is 19. 20 squared is 400, and the square root of 400 is 20. Now, the next thing I want to talk to you about is irrational numbers. There are only a few perfect squares. The square roots of other whole numbers are irrational. So, for example, the square root of 5 is irrational. Irrational numbers never repeat and never end. Though this one has 2 7s here, the rest of it does not end, and it doesn't repeat. So certain numbers might repeat in the middle, but they don't keep repeating. The square root of 23 is an irrational number. It never ends and never repeats. So the other whole numbers are irrational and therefore are not perfect squares. So our concept check. Which are not perfect squares? Well, 1 is a perfect square, 4 is a perfect square, 5 is not, 9 is a perfect square, 16 is a perfect square, 23 is not, 25 is, 36 is, 49 is, 64 is, 66 is not, 81 is, 100 is, 108 is not, 121 is, and 144 is. The next thing that we're going to do is talk about cube roots, and then that'll be the end of our lesson. So the next thing that we have here, it says a cube root of 27 is 3, because 3 times 3 times 3 is 27. So a cube root is a number that is raised to the 3rd power. The cube root of 1,000 is 10, because 10 times 10 times 10 equals 1,000. And sorry, we added an extra 0 in there. I don't know why Mrs. Slack did that, but okay. And it says, what is the cube root of 8? The way that we write that is this way. The symbol is this. So our cube root of 8, and the way that we write that is cube root of 8 is 2, because 2 times 2 times 2 is 8. Okay? So now let's go through our cube roots and our cubes. Our perfect cubes from 1 to 20. And again, now that you know, we can use our calculators. In this respect, our calculators, we are going to use the button, and I'm going to put this at the end. We're going to use our button on the white button. I want to say it's the same one. Yep. It's the button, the arrow that goes like this. So when you put it in your calculators, for example, 2 to the third power would be 2. You're going to hit this key, 3, and that would give us 8. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. And then the cube root of those, so the cube root of 1 is 1. The cubed root of 8 is 2. The cubed root of 27 is 3. And the cube root on our calculators, we would have to put in, to find the cube root of a number, is, I gotta find it. Oh, it is the second button. So we would hit the 3. We would hit the arrow button and then our 27. So 3, the second button, and that arrow button. And then our 27, and it would give us our answer. So that's how we would do that. So 4 to the third power, or cubed, would be 64. So the cube root of 64 is 4. 5 cubed is 125. The cube root of 125 is 5. 6 cubed is 216. So 216, the cube root of that is 6. 7 cubed is 343. And I'm going to kind of just go down this row here. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So to find the cube root of those, the cube root of 343 is 7. The cube root of 512 is 8. The cube root of 729 is 9. And the cube root of 1,000 is 10. So then 11 cubed is 1331. 12 cubed is 1728. 13 cubed is 2197. 14 cubed is 2744. 15 cubed is 3375. 16 cubed is 4096. 17 cubed is 4913. 18 cubed is 5832. 19 cubed is 6859. And 20 cubed is 8,000. So the cube roots of those, so 1331 is 11. 1728 would be 12. 2197 is 13. 2744 is 14. 3375 is 15. 4096 is 16. 4913 is 17. 5832 is 18. 6859 is 19. And 8,000 is 20. That ends our lesson.